All right, so now we're going to turn the corner and go back to just our regular series. And we're going to do more tests. So we're going to be doing tests on series that have -1s in them. So this first test is called a ratio test. And we'll be asked if something is absolutely convergent, conditionally convergent, or divergent. And as we move on, I'll talk more about what that means. But let's look at this first ratio test. So this ratio test, I want to use, or it's useful when there's lots of exponents, and it's really necessary to do when there's factorials in my initial sum. So how do we do it? So given this sum, I'm going to take the ratio, the limit of the ratio of the n plus first term over the nth term. And when I do that limit, and take the absolute value of that limit, I get a number L. If that number L is less than 1, then I have the conclusion absolutely convergent. If I have a number bigger than 1, then I get the conclusion divergent, and equal 1, do another test. Okay, so let's look at this here. So it'll say AC, CC, or D. That'll be how, before we had the question, converge or diverge. Now we're going to have AC, CC, or D, and this is going to be my expression. So let's look at this, delineate what A sub n is. So A sub n is this term, -1 to the n cubed over 3 to the n. So A sub n plus 1 means put an n plus 1 everywhere there's an n. So -1 to the n plus 1, n plus 1 cubed, 3 to the n plus 1. So the ratio test says take the limit as n goes to infinity of the n plus first term over the nth term. So here it is. So this is the n plus first term divided by the nth term. I've always got division by a fraction, so I'm going to multiply by the reciprocal of this. And so that's what this is. And I took the absolute value. See how I just threw away the -1s? Because I have absolute value, these will go away. And I know these n terms don't need an absolute value because they go from 1 to infinity, right? The n terms go from 1 to infinity. So the absolute values, toss the -1s, multiply by the reciprocal, I get to here. Now I'm looking to do the limit with the highest powers. So let's be careful with this 3 to the n plus 1. So 3 to the n plus 1 is the same as saying 3 to the n times 3 to the 1, correct? So by splitting it up, I can see that the 3 to the n's will cancel. And I'll still have a 3 in the denominator. Taking the highest powers, I don't want to multiply this out, but I find that there's the highest power in here would be n cubed. And the highest power from here would be n cubed. Excuse me. Carry along this 3. Cancel, I get 1/3. This is the number L that they're talking about, the limit. Since this is less than 1, I get the conclusion that this is absolutely convergent. Okay, let's do one more. So here it is, AC, CC, or D. All right, so just for practice, I'm going to write out what the A sub n plus term is. You don't need to do this. I'm just going to write it in. So I'm replacing n plus 1 everywhere there's an n. So I'll get n plus 1 minus 1, so it'll be n plus 1 plus 2 over 3 to the 2, n plus 1 like that, right? Okay, so here I go. Limit as n goes to infinity. And I've got the absolute value bars, and I'm tossing the -1s, right? Well, maybe I'll just write them in one time. Let me just do it one time so you can see. So here I'd get n plus 3, 3 to the 2n plus 2 over. Okay, so because of the absolute value bars, I'm going to cancel the negatives. So I get n plus 3 over 3 to the 2n plus 2 multiplied by the reciprocal. right? And I don't need absolute value bars because the n's are always positive. So I got rid of the negatives. And so you can go right to this step if you'd like. Let's see. So what I want to do is I want to make sure I'm canceling correctly. So I'm just going to carry this along. And this is times 3 to the 2n. So this is the important one to break up. This is the same thing as saying 3 to the 2n times 3 squared times n plus 2. So I'm looking for the highest powered terms. So in the numerator, if I multiplied this out, I'd get n times 3 to the 2n. Well, actually, before I go doing that, let's cancel what I can, right? Let's cancel the 3 to the 2n's because everything is multiplied, yes? Okay, now let's go find the highest power term. From the highest power term in the numerator, I had n. Highest power term in the denominator, this would multiply times this, so I would have 9n. Right, and this one just fades off in the distance. So does this one because of highest powers, because I'm doing limit with infinity. I can cancel the n's. I get 1/9. Since this is the limit, right? This is the L. This is less than 1. I get therefore this is absolutely convergent.